A polynomial in one variable x of degree n is an expression of the form p of x equals an x raised to n, an minus 1 x raised to n minus 1 plus etc. a1x plus a0, where a0, a1, a2, etc. an are constants and an not equal to 0. They can be linear, quadratic, cubic or higher degrees of x. To get their zeros for a linear polynomial p of x equals ax plus b, it is minus b by a. For a quadratic polynomial, we need to factorize by splitting the middle term to get its two zeros. And for a cubic polynomial, we factorize it by trial or long division method and then by splitting the middle term to get its three zeros. In this section, we are going to discuss more on this long division method to factorize a polynomial and to get its zeros. Let's try with an example. Divide the polynomial x plus 3x square plus 1 by 1 plus x. This is a division of quadratic polynomial by a linear polynomial. In the long division process, we continue the division until we get the remainder as 0 or if its degree is less than that of the divisor. Here we get the remainder as 3. Also, as dividend equals divisor into quotient plus remainder, we can write 3x square plus x plus 1 equals x plus 1 into 3x minus 2 plus 3. Now let's see in detail with another example. Divide the polynomial 5x plus x cube minus 3x square minus 3 by x square minus 2. Here the dividend is a cubic polynomial and the divisor is a quadratic polynomial. The first step is to obtain the first term of the quotient. Divide the highest degree term of the dividend by the highest degree term of the divisor, then carry out the division process. So here x cube by x square equals x is the first quotient. Now multiplying the divisor with the first quotient, we get x cube minus 2x. Subtracting it from the dividend, we get minus 3x square plus 7x minus 3. Now the second step is to obtain the second term of the quotient. Divide the highest degree term of the new dividend by the highest degree term of the divisor and then carry out the division process. So minus 3x square by x square equals minus 3. The result after the division process is 7x minus 9. This step is repeated to an extent when we reach the final step, that is when the degree of what remains is less than the degree of the divisor. So we cannot continue the division any further. Here, since the degree of 7x minus 9 is less than the degree of x square minus 2, further no division takes place. So the quotient is x minus 3 and the remainder is 7x minus 9. Also, when we multiply throughout x square minus 2 into x minus 3 plus 7x minus 9, we get x cube minus 3x square plus 5x minus 3. Thus, dividend equals divisor into quotient plus remainder. So, we can generalize this statement in polynomials as if p of x and g of x are any two polynomials with g of x not equal to 0, then we can find polynomials q of x and r of x such that p of x equals g of x into q of x plus r of x, where r of x equals 0 or degree of r of x is less than degree of g of x. This is known as the division algorithm for polynomials. Let's see another example. Find all the zeros of x raised to 4 plus x cube minus 5x square minus 3x plus 6. If you know that two of its zeros are root 3 and minus root 3. Since two zeros are root 3 and minus root 3, x plus root 3 into x minus root 3 equals x square minus 3 is a factor of the given polynomial x raised to 4 plus x cube minus 5x square minus 3x plus 6. Now divide this polynomial by x square minus 3. So this is a division process of a polynomial with degree 4 by a quadratic polynomial. Here too we follow the same steps as we divided a cubic polynomial. After getting the 3 terms of quotient, we get the remainder as 0, which is the end of the division process. Now by division algorithm, p of x equals g of x into q of x plus r of x. Substituting the values, we get x raised to 4 plus x cube minus 5x square minus 3x plus 6 equals x square minus 3 into x square plus x minus 2. Factorizing x square plus x minus 2, we get x square minus 3 into x minus 1 into x plus 2. Now x square minus 3 can be written as x plus root 3 into x minus root 3. So now we have all factors of the polynomial with degree 4. Therefore, the zeros of the given polynomial x raised to 4 plus x cube minus 5x square minus 3x plus 6 are root 3, minus root 3, 1 and minus 2. So we can conclude that the division algorithm for polynomials in one variable x is if p of x and g of x are any two polynomials with g of x not equal to 0, then we find the polynomials q of x and r of x such that p of x equals g of x into q of x plus r of x, where r of x equal to 0 or degree of r of x is less than degree of g of x, and it is used to verify the long division method to factorize higher degree polynomials and to find the zeros of higher degree polynomials.